What if I told you that the bridges you drive over, the skyscrapers you admire, and the roads you travel every single day were all designed inside a computer before a single piece of steel was ever cut? Engineering design software has completely transformed civil engineering, and today we are going to dive deep into the tools that are literally building our world. Let me take you back just a few decades. Civil engineers used to work with paper, pencils, and massive drafting tables. Every line had to be drawn by hand. Every calculation had to be checked manually. A single design change could mean redrawing an entire set of plans from scratch. It was slow, expensive, and honestly pretty exhausting. Then computers came along and changed everything. The first major shift came with something called CAD, which stands for Computer-Aided Design. Auto CAD launched back in 1982. And it was a total game changer. Suddenly engineers could create precise drawings on a screen, copy elements, make changes in seconds, and print professional blueprints without touching a pencil. It sounds basic now, but at the time it was genuinely revolutionary. Engineers who had spent years mastering hand drafting had to completely relearn how they worked. But CAD was just the beginning. Modern civil engineering software goes so far beyond just drawing lines on a screen. Today we have something called BIM, which stands for Building Information Modeling. Think of BIM as a living, breathing digital model of a structure. It is not just a picture of a building or a bridge. It is a full three-dimensional model packed with real data. Every beam knows its own material properties. Every pipe knows its diameter and flow capacity. Every foundation element knows the load it is carrying. Software like Autodesk Revit and Bentley Open Buildings are leading examples of BIM tools used in civil and structural projects. When you change one element in a BIM model, the entire model updates automatically. If you decide to shift a column 2 feet to the left, the software immediately flags any beams, pipes, or electrical systems that are now in conflict. That kind of real-time problem detection used to require weeks of coordination meetings between different engineering teams. Here is a fascinating example of what this technology can do. The planning and design of the Crossrail project in London, which is now called the Elizabeth Line, involved over 10,000 different engineering components being managed inside a shared BIM environment. Teams from multiple countries were collaborating on the same digital model simultaneously. The complexity would have been nearly impossible to manage with traditional methods. BIM made it possible to coordinate everything before anyone broke ground. Now let us talk about simulation software, because this is where things get really exciting. Programs like ANSYS and SAP 2000 allow civil engineers to simulate how a structure will behave under all kinds